Okay, excellent. Well, welcome to another ICCS Journal Club. This is the November 2024 edition. This week we have Chris Edsall, who is one of the co-directors at ICCS, sort of responsible for the software engineering side. He's also the head of research software engineering here at the University of Cambridge. He's going to be giving our Journal Club today on what RSE can do for researchers.
Thanks, Dominic. So I don't need to repeat the slides. That is exactly what Dominic said. But this is Journal Club, so I thought I would start with a couple of journal articles to set the scene. Both first authored by a guy called Greg Wilson, who you may know from his other work, software carpentry, well, some of his other work, software carpentry. He also wrote some books, The Architecture of Open Source Programs and other things, but mainly known for me as the founder of Software Carpentry. He'd been teaching since 1998 and took those experiences and with some colleagues wrote them up into this paper in 2014 called Best Practices for Scientific Computing. And we would recognize a lot of the things that are recommended in that paper. They have 24 recommendations for things like naming, code style, how to build a workflow, version control, build tools, modularization, unit testing, and so on. So very much, you know, the day-to-day work of research software engineering was written down in that paper, and that was their recommendation to the community. 3 years later, in 2017, they presumably with their tail between their legs, they wrote a second paper called Good Enough Practices in Scientific Computing. What they recognized was that the 24 recommendations was just too much. That people, you know, researchers are busy. Writing perfect software isn't aligned with their main goals, and so therefore the second paper, the Good Enough Practices, was basically the minimum viable product, the minimal set of practices you could get by with for doing research software. Those aren't the only papers to do with research software engineering, and in fact, if you take the R off, if you consider software engineering in the whole, we've been doing it since we invented computers in the 1940s. And people have been thinking about, since they stopped plugging things together, wiring things together hardwired, and started writing software, they've been thinking about how that software is written, how that software is engineered. So there's a long history of research into software engineering, and that's where the practices that we are trying to bring into the research domain come from. So, you know, the reason why it's good to do unit tests, why spending time on that pays back more than not doing it. That research is in the literature of software engineering. Research software engineering, though, is a newer field. So about 3 years ago, it celebrated its 10th anniversary. So must be about 13 years ago now. Yeah. I'm sure Marion, who's on the call, can pinpoint the particular collaborations workshop where the term was coined. And so we have a smaller history of the practice of research software engineering, and so the research into research software engineering isn't as mature. There has been some work from colleagues in Southampton and the Software Sustainability Institute to survey the practitioners, the people who are doing software engineering in a research context, whether they call themselves RSEs or not. They can reply to these surveys. They've run several of them now. The link I've got on the slides there is to the results of the 2022 survey. And that's quite interesting and drives some of the patterns we're using in the team. For instance, if you look at the preferred number of projects per research software engineer in that survey, the answer is 2, and that's what we try and aim for in our team. That said, people are now starting to look into it. Dan Katz from the University of Chicago is a prolific author in this space. And at the URL there, the IRSER one on GitHub, there are collected together quite a few resources about the research into research software engineering. But that's possibly a little bit meta. Let's bring it back to climate science and the practitioners of climate science researchers. So Julius Biszecki from the M Squared Lines team wrote this blog post. If you note the date, it was right in the middle of the cross-Vesry meeting we had in Cambridge earlier this year, where he makes the case that as a researcher in climate science, you should be able to do some level of research software engineering. So when I was asked to speak on this topic, we had a particular audience in mind, but then when I thought about it, I could identify some other people for whom research software engineering is of benefit. So there are different stakeholders, different communities, each of whom want different things out of RSE, or RSE can offer these groups different things. So we'll look at funders, researchers themselves, groups of researchers, in a particular field, the principal investigators who manage those research groups, the broader scientific community, and widening it out to the entire planet. They also have a stake, all of us have a stake in better software engineering. The easiest sell is to funders. So the classic way that research software is developed is by a PhD or a postdoc who's probably a domain expert in whatever the research field is, but not necessarily software engineering. They do the minimum software engineering on the software to get the paper written and out the door. And the minimal software engineering probably doesn't include niceties like documentation or version control or tests or anything like that. And so that piece of software winds up being maintained by the author who wrote it only for the length of time that that author stays in the research group. And if they're a PhD student or a postdoc, they move on after just a few years. Because the effort wasn't put in at the time of the software's creation, once the original author has moved on, that software is practically unusable to the other members of the group. That's not great if you're the person responsible for paying for the development of that software, because presumably whatever the research question is hasn't gone away. Physics didn't stop when the postdoc left. And so you would still need software to carry on the research in that field. You might need the same software, or you might need to further develop the software you had. And so funders would rather not pay for that again, since they've already paid for it once. So the sell for research software engineering to funders is easy. Gives them a better return on their investment. And that's where we saw the money and the push come from in the UK. It'll take too long to go into the funding structure of research councils and government research funding in the UK, but the one who cottoned on first, presumably because their domains had much more of this sort of software in them, was the Engineering and Physical Sciences Research Council, the EPSRC. One of the first things they did was set up these 5-year-long research fellowships in personal fellowships in research software engineering, and that enabled people to go out and set up groups in a university because their funding was assured for 5 years, and they could build a group around themselves and have some sustainability of people. And also spread the good word about research software engineering. So this was happening, at the time I was a practitioner. I was in a group funded by a different research council who hadn't got the message about RSE, and we didn't even know the name or the term existed. We knew we wanted those people, but we didn't know what they were called, and we didn't know, those of us who were doing it didn't know that's what we were doing. So the EPSRC funded these fellowships. They also fund an organization called the Software Sustainability Institute, which has some people in it, and they put on events, and they also do fellowships, not big 5-year long ones, but small fellowships. If you're an RSE and you have an idea that you think is worthy, they have periodic calls for their fellowships. I think one has just closed recently. And they also have my favorite slogan, better software, better research. And in fact, you could probably sum up the entirety of this talk. If you only take away one thing from it, it should be those 4 words: better software, better research. Another funder who was interested in this concept was Schmidt Sciences, or Schmidt Futures as they were at the time. They also recognized this need for software engineering, although coming from the US at the time, the term RSE hadn't sort of made it across the Atlantic or permeated all the way through. But they certainly saw a need for this, and within the VESRI project, or connected to the VESRI project, they funded our institute, the Institute of Computing for Climate Science. And also because they see the value in this, and this is a good model. There are 3 other of these virtual institutes of scientific software. So the ICCS is unique in that we've got one domain we look after, climate science. The other 3 VIS centers span all areas of research. But this idea that you should have people who are experts in software engineering collaborating with researchers to make the research software better is something that the funders support. Others like Wellcome Trust or the Chan Zuckerberg Foundation also do the same. So that was funders. If you're a researcher yourself, why would you bother about research software engineering? It's reasonably easy to sell. One of the first ones is papers which have code in them get more citations. So if you're looking at your career and if citations are important to you, then that's a recommendation for publishing your code alongside your research. And if you're going to publish your code alongside your research, you'd be less embarrassed if it had had some good software engineering applied to it. Other things that are a benefit to an individual researcher are that it will make you more efficient in the end. So it might take you some time to learn about Make or CMake or SCONS or whatever the build system for the language you are using is, or that you would prefer to use. But that effort will be repaid after, probably after the second project, really. But certainly, by the end of your career, that the time you spent learning the tools will be repaid multiple times. The quote there is apparent. I did a little research this afternoon to see if I could verify that, and quote, investigators say it should not be attributed to Abraham Lincoln. He probably never said, if I have 8 hours to chop down a tree, I would spend the 6 hours of those sharpening my axe. But it's a good idea. If you apply some other techniques like testing, that will mean that you have fewer hard to find bugs, fewer hard to debug issues. If you've got testing and version control, you can do a thing called continuous integration, which will allow you to find the bugs as they are added to the code base rather than much later on. It's much easier to fix a bug when you know what changed, because it's the thing you just changed in the last commit. Another software engineering technique that pays back is factoring out the common aspects of your code, modularizing them, and then turning them into packages so that you can reuse the code. You spent a lot of effort writing the code the first time. If you put just enough effort to package that up so it's nicely reusable, then you can just pick it up off the shelf and use it in your next project, knowing that the software is good. One reason you might want to do it is now that it's a requirement. Some journals are requiring code submissions to go along with the paper. So Dominic pointed out that GMD, Geophysics Model Development, says every paper must include a section at the end before the acknowledgements entitled Code and Data Availability. And finally, if you decide to pack it all in and go and do high frequency trading or whatever, you'll find that these skills that you've learned while doing research software engineering are transferable to other industries. Science is a team sport. You are unlikely to have been the only person doing your research. You're likely to be in a research group, and why research groups will find software engineering practices useful is that it enables sharing the knowledge of both the problem domain, so the hard one, knowledge of what the problem is, and also the knowledge of the implementation across the group. And one of the best ways to do that is with documentation. If you are writing documentation, it would be great if the documentation system were automated. So as you do a build of your code, you also do a build of your documentation, more likely to stay in sync that way and be useful. Other ways of sharing knowledge across a group using software engineering practices is in your code hosting solution, be it GitHub or GitLab or Bitbucket or whatever, with the discussions on pull requests and on issues, there's a lot of valuable knowledge gets shared via that process. That works really well if you have a distributed research group as well. If you've got some people on one continent and some on another, some people in one time zone and some people in another, having those things written down in either documentation or in your versioning control system is useful. Another way of spreading the knowledge is about the project management level, the software development management, via a technique the Japanese invented called Kanban. So I think it came out of Toyota for tracking parts in a car factory, but it turns out it's also useful for tracking work in a software code base. And we make extensive use of that in the ICCS. When we engage with one of your projects, we would ideally set up a GitHub project board, and then we can look at all the pull requests and issues that we're doing, see where we are with them, figure out what the milestones are, what the releases would be. So all of those software engineering practices help spread the knowledge within a research group. And also, if you did it the classic old school way of everybody hacking on a software project on a network drive, and not using version control, then you'd be forever standing on each other's toes, wiping out each other's development work. So using version control systems like Git enables multiple people in the group to work on features simultaneously, which increases the velocity of development, the speed of development of the group. Why would a PI be interested in research software engineering? This is more stick than carrot. And there's an entire talk on reproducibility in this Journal Club series. So from almost a year ago now, just over a year ago now, in 2023, Marion gave a talk, and there's a screenshot of it there. I'm not sure if you can see it. It's a bit blurry at my end, but there's a science paper, a science article about retractions. And basically, you know, as a researcher, as a PI with a reputation to uphold, retractions is probably the last thing you want. So it would be awfully embarrassing if you had to retract based on a bug in your software, or some software that just could not reproduce your main conclusion. And that unfortunately does happen. Why else? So more existentially, why are we doing science? Why are we doing this research in the field of climate modeling? It's so that we can improve the climate models, and it's not really of much use if we just improve our local build that runs on our site's HPC and no one else gets to use it because the software engineering wasn't put in to make it reusable. The benefit comes when the software is used by multiple research groups, by the community. So yes, papers are good, but real impact comes from getting your parameterization or your technique upstream in a global circulation model. Upstreaming that, because the people who run these GCMs have necessarily have quality assurance controls. They don't just take any random contribution. So you have to make sure that if you are contributing to one of these, if you're upstreaming your code into one of these models, that the code that you're contributing is of good quality. If you are applying for more funding and that funding includes proposing writing software, funding agencies would look more kindly on it if you have a track record of providing high quality software. So doing it well now will enable you to hopefully get more money in the future. Doing good software engineering helps develop your people. So they will in turn become PIs, or work package leads and PIs of their own groups. It's easier to recruit if your research group is known as producing good quality research and good quality code. I mentioned that people will move on. Good quality research code is known to be, some of it is quite old now. It's gone through several generations of supercomputers. I think the UK Met Office's unified model has gone from scalar to vector to massively parallel to GPU, and you can still see all those the way that they architected the code for those different architectures is still around, even though the computers are long gone, and possibly some of the authors, at least retired. Having good research software engineering practices means at the end of a project, when a project wraps up, you have a high quality handover. So you don't just get a pile of spaghetti code you know nothing to do with, you don't know how to do anything with. You have a product, well, an artifact that is useful to you in the future. If you talk to research software engineers, you've got access to people who are expert in software engineering. So we know a lot of techniques, and we can advise on which of those are appropriate to your projects. The other thing about research software engineering, one other thing, is that it's quite cross-discipline. So perhaps this applies more to the other VIS centers than it does to ICCS, but certainly we've got some people in the team who have experience of fields well outside of climate research. And that means they know of techniques, so numerical methods, solvers, libraries, and things that have been applied to problems in other fields. And if they're in dialogue with your research group and can see a commonality between what you're doing and something from a completely different field like fusion or bioinformatics or something like that, then we can call on those techniques and methods. And so the model we prefer to work with is the collaborative model. That is, that we work with you rather than working for you. So why does the scientific community need research software engineering? You have this virtuous circle if you do your science openly. So this is from a paper. Unfortunately, my notes are covered up by the screen sharing thing. Paper titled "Research Software Engineering Accelerates the Translation of Biomedical Research for Health." So published in Nature, but it shows the virtuous cycle of what can happen when you start applying these research software engineering techniques, particularly publishing the software and software citation, and that's a sort of rising tide that lifts all the boats in a particular research community. Speaking of research communities, there was this funding call I bid into a few years ago. It was quite interesting. It was the first time that the UK government's funding agencies recognized the need for software maintenance. So they were usually funding the creation of new software rather than fixing or improving current software. So they set aside £4.5 million. I believe this call got something like 400 proposals, and they funded about 30 of them, so I don't feel so bad about missing out. But one of the interesting things was the criteria on which they were judging these applications. What they were preferring were research codes which had a community, evidence of a community, like mailing lists and conferences and user groups and things like that, compared to single researcher pieces of software. And so the way that you get a community around your research software is you have good software engineering practices. That makes the software attractive to many more people. If your software is not reusable, you'll be the only person using it. And so scientific communities would prefer a fewer number of well-engineered pieces of research software, because that has more value to the community. Speaking of the community, since this is Journal Club, I'll mention a couple of journals. The one on the left in blue is, if you're not colorblind, is the Journal of Open Source Software. And the concept of that is that you can write a paper. The currency of academia is papers and citations. And previously, the way that you got word out about your software is you used it to make a scientific breakthrough, and then you documented both the breakthrough and your code in the one paper. The idea of the Journal of Open Source Software is to separate that. You don't need a breakthrough to be able to write a paper that's just about the software. I think that the barrier to publishing is reasonably low. The information that's needed to form a complete JOS paper is minimal. I think their rule of thumb is you should be able to write one in an afternoon. And so that's a useful way of getting the word out to the community about pieces of software that people might be able to reuse. The review process involves a big checklist and going through some of the software engineering practices and making sure that the author of the software that's going into JOS has applied them. So things like unit testing and version control and releases and things like that. On the right in the green is a sister journal to JOS, HOSE, the Journal of Open Source Education. And one of the roles of research software engineering is training. So I tell my team that RSE is about continually learning and also continually training, continually telling other people what you have learned. And so to make educational materials reusable, that's the purpose of the Journal of Open Source Education. And Jack and Jim from our team, I think, recently published some material related to the summer school, a machine learning workshop that they had. Finally, another group of people who have a vested interest in good software engineering practices flowing through into good research software are the people who make policy decisions and, on the behalf of the wider society. We went through a pandemic in 2020. And as a result of that, there were some policy decisions taken for lockdowns, which affected, more than 1 billion people. And the policy makers were making their decisions based on the output of research software. And that was a wake-up call for that community. And they have improved their software practices. I think you could say that climate change is going to affect at least 8 billion people. And if we are going to make decisions based on our software, we better be quite sure, as sure as we can be, that our software is doing what we intend it to, and the results that it's producing are the ones that it should. If you're interested, by the way, this is a really nifty piece of software on the internet called En-ROADS from MIT. It's got a whole bunch of models behind it. You can tweak those sliders and see what sort of a difference that would make if you applied those policies to the global average temperature. Here's another piece of work from the ICCS teams. This is from Dominic and Rowley. And this is to do with the transparency of the results. So quite often there's a lot of data processing goes on after the raw model output has been made. And the question is, what certainty do you have in the figures in, say, the IPCC's Sixth Assessment Report or advice to policymakers? Can you track that back to the provenance of the data that went into that figure? So that's a very interesting piece of software engineering that's going on in ICCS at the moment. You may have noticed this is a thinly disguised advertisement for research software engineering. So here is a word from our sponsors. If this interests you, if you would like to do more research software engineering, if you don't know where to get started but want to ask, you can engage with the team here at the Institute of Computing for Climate Science. We have various methods of engagement. Our flagship offering is allocating resource to work with your project for a certain amount of time, usually 3, 6, 9, or 12 months. You get 2 RSEs, although each working at half time. So about 1 RSE in total effort, but spread across 2 people for the reasons I mentioned earlier about bus factor, also about development velocity, including techniques like code review is much easier if you have 2 people who can do that. So we have a quarterly call for proposals to be supported by the ICCS. The next quarter, so the first quarter of 2025, applications need to be in by the 9th of December, which is about 4 weeks away now. If you are in a Vesri project and you're thinking, hey, I could do with some software engineering effort of that scale applied to my problem, the polite thing to do would be to talk to the PI of your project, because they can coordinate, how many applications are going into the ICCS. Another way you can engage with us is code reviews, and that's where we look at your code from a software sustainability point of view. So we apply a couple of checklist processes to it, and we provide you a report at the end with identifying things that are going well and areas where a little bit extra RSE, a little bit extra software engineering effort could make the code a whole lot better. Going down in sort of scale, we also offer the Climate Code Clinic, which is where you get to talk to a couple of our RSEs for an hour or so. And you don't have to wait, quarterly to do that. There's a form on our website, which is that one right at the bottom, iccs.cam.ac.uk. And you fill in that form and we pick those up. We're on a schedule once per week and assign people to look at your query. For the past 3 years now, we've run a summer school. I mentioned training before. That's our flagship training event. It will be in July. If I got that wrong, Marla will correct me. But I believe it will be in July in Cambridge in 2025. Also, if your group has identified a specific training need, we can tailor a training offering to that. So, for instance, Calypso identified a training need, and we went and taught Git and GitHub to them. And also, we've done co-located trainings with other large conferences like the World Climate Research Program conference in Kigali last year. We sent some people there to Ames to provide training. And that is my last slide.
Right. Thanks very much, Chris. Round of